everybody. We're Group 5, and today we're going to be talking to you about the Trash Chimney, a trash collection system for the world's rivers. I'm David, an aerospace engineering major.
I'm Justin, an electrical engineering major.
I'm Jaden, a material science and engineering major.
And I'm Kevin, a civil engineer.
Most of us live in dorms, and one of the many conveniences provided is a disposal system. You go to the trash room, throw your trash down the chute, and your day is done. However, not everyone has this convenience. When we were conducting our research about pollution, we found out that 80% of river pollution is spread out between 1,000 different rivers. And it was commonplace for people who live near rivers and had poor disposal systems to dump their trash in rivers. This isn't a good way to do things, as these rivers flow into the ocean and cause more pollution to build up. For this reason, we want a way for people to collect trash, detect how dirty the water is, and for it to be a portable and functional product for everyone to use. Next up is Justin to discuss our design process.
All right. Through our design process, we drew inspiration from current river collection systems and used criteria like portability and easy use to define what we wanted in our product. We knew that we wanted to make a small-scale product that mimicked our future product to create a proof of concept and make sure it worked. After brainstorming, we made a prototype that best fit our problem. Our solution consisted of a three-part section product: a physical trash system capable of indicating to the user problems that might occur in the system, such as a full trash net or an indicator for flooding, a physical barrier separating the trash from the microplastic, and finally, a microplastic sensor, which will be implemented in the future. As you see on the slide, on the top right of a slide, you can see our first prototype, and it was made out of cardboard. This was a great way for us to create a structure for our product and see what we needed in our product. Going forward, we made our second prototype, as you can see on the bottom right, which further implemented our system and created a proof of concept. Next up is David with our logic flowchart.
So this is our logic flow chart, and it explains how the electronic portions of our system are going to work. As Justin mentioned, we're going to have two sensors in our system. The first is going to be the laser sensor, and the second is going to be a water sensor. On the left side of the chart, we're going to follow the laser sensor, and it's going to be placed right in front of the trash net. So if it detects a full load of trash in the net, the laser will be triggered, and that'll turn the yellow LED light on, and the display will then read that the trash is full and it needs to be taken out. On the right side of our chart, we see the water sensor, and if the water sensor is detecting high levels of water in our system, the red LED light will then turn on, and the display will read the water isn't safe. If both of these sensors aren't indicating any problems within our system, the green LED light will remain on, and that'll indicate to both the people using the system and to the display that the water is safe. Next up is going to be Kevin, who's going to talk about our future works and testing results.
After making our product, we went around to multiple people and asked them to try it out. After trying it out, we got pretty positive responses, as you can see from the chart. And most people thought that it was not too complicated to use. However, some people thought that they might need some training or some more explanation, as it can get complicated at some times. One request that we got a lot was that a manual would be required. We also want to make sure that our product is waterproof, as we're working with electronics and we don't want the electronics to get damaged and become non-functional. We also want to make sure that all rivers can work with our product, as we want to make sure that we have pneumatics to change the size of our product and to have some way to make our product accessible so that fish can go through, but plastic does not. Thank you for listening to our presentation. I hope we have piqued your interest. Thank you.